So in this question, we are going to learn how to calculate the net impulse when there are more than two forces acting, and some of the forces acting from time to time. Sometimes the force is acting and sometimes it's not acting, and how to find the net impulse. So let's proceed. A boy rides a scooter pushing on the road with 1 foot with a horizontal force that depends upon time, right? So the force is varying, so it acts from 0 to 0.5 seconds for 100 Newton force the boy is applying. Then the boy stops, and then at 1.5 second again applies for half a second, again 100 Newton, right? You can see over here, right? And then again stops and then again applies, right? So this is the impulse which the boy is applying, right? So this impulse the boy is applying towards right, and we can find simply that impulse by summing up the areas, right? So here it is 0, so we can sum up the area, right? And all three are equal, so let's find just one of them. So that is going to be 100 Newton multiplied by for the half a second, right? So this is half a second, this is 50 Newton second in one area multiplied by 3. So that's going to give us 150 Newton second is the impulse which the boy has applied, okay? While the scooter rolls, a constant force of 25 Newton opposes the motion, right? So there's a continuous force of 25 Newton which is opposing the motion, right? So that is going to be negative. So there's another impulse which is acting towards left, and it acts for the whole time, right? The combined mass of the boy and the scooter is 25 kg. So the mass which we are interested in is 25 kilogram. I'm just writing it down. Find the speed of the toy above the boy after 4 seconds, right? So the time of interest is 4 seconds. So this force, which is 25 Newton, is going to act for 4 seconds. So this is going to give us 100 Newton per second. Impulse towards left. So net impulse net is going to be 150 towards right minus 100 Newton seconds towards left. So net impulse which the cycle is going to experience is 50 Newton seconds, okay? I'm going to find what is going to be the speed of the boy, assuming that starts from the rest, right? This impulse net is going to be equal to my change in momentum, okay? It's going to be mass into final velocity minus mass into initial velocity. Initial velocity is given to be 0. So this is going to be simply mass into V final. So we know this is 50. So this is going to be 50 is equal to mass of the boy into V final. And the mass of the boy and the scooter combined is given to be 25. So that's now very simple. So 25 into V final. And the V final is going to be equal to 50 by 25. That's going to be 2 meter per second. Okay, so that's the final velocity of the boy. And we did this by finding the net impulse. Okay, one acting towards right, one acting towards left. Now we have to draw the graph to represent the variation of the boy's speed with time. So we're going to do it roughly. Okay, so how the boy's velocity actually varies with time. Okay, so during the first half a second, okay, the net impulse is going to be 50 minus 25 into half a second. Okay, so that is going to be equal to 50 minus 12.5, and that is going to be equal to the final velocity of the boy. Okay, so mass is 25 into V final, right? So when boy starts, we are going to just draw a rough graph. Its velocity is going to actually increase, right? Its velocity is actually going to increase because the net impulse is higher. So first its velocity is going to increase like that, okay, for 0.5 seconds, and then from 0.5 to 1.5 seconds, basically there's a net impulse towards the left, right? Because this 50 Newton stops acting, and basically Newton second is not there. So whatever impulse is there because of this negative direction, right? So the velocity will start to decrease, and basically will start to decrease, right, all the way to 1.5 seconds. Okay, and then again it will increase, then again decrease, again increase, again decrease, like that. Okay, so this is how we'll get to the final speed, right? So this is going to be velocity varying with time, right? So important point is that it will increase, and when there's a second impulse acting, it will decrease, then it will increase again, maybe to the higher level, then come down, then again increase to the higher level, then come down, and then increase to the higher level, like that. Okay, so we can draw a zigzag velocity time graph for the boy, and that is going to be our answer.